Okay, guys, so it is time for biology. There's actually a song called the Biology Song. So, it's actually pretty funny. Should look it up on YouTube, called the Biology Song. It's a cartoon. Anyway, if you want a little comic relief, it's kind of fun and it's also educational. I want to talk about biology. So when I was talking to you on the last video about one of the things that makes people in the at-risk phase different from people in the recreational phase is that they begin to use exercise to avoid negative consequences emotionally, particularly to avoid the unpleasant emotions such as stress or anxiety or depression in their lives. And for the at-risk exerciser, exercise begins to become sort of a more primary mechanism or means for dealing with emotional states that are uncomfortable. And I kind of alluded to the fact that there is some biological data to explain why that might happen. And since, health psychology, as you know from day one, uses the biopsychosocial spiritual model, I always like to bring in as many aspects of that as possible to explain a phenomenon. And so in this video, we're going to talk about the biological mechanisms that explain why exercise does impact mood and how that can move somebody to an at-risk category and therefore beyond that towards problematic and eventually exercise addictive behaviors. And so we have several hypotheses here and findings that I want to explain to you. The Thermogenic Hypothesis, the Catecholamine Hypothesis, the Endorphin Hypothesis, the dopamine findings, and frontal lobe asymmetry studies. There aren't that many, but they're kind of provocative and interesting. So the idea is that one of the reasons that people in that at-risk category get to that point from just starting out as recreational is that there are chemical changes in the brain that exercise actually induces or influences. And a researcher by the name of Griffiths proposed, after studying folks who were, quote, exercise addicted, proposed 3 possible biological mechanisms for connecting the mood changes, improved mood state, to exercise behavior. The Thermogenic Hypothesis, the Catecholamine Hypothesis, and the Endorphin Hypothesis. So the Thermogenic Hypothesis essentially indicates that exercise will raise your body temperature, and that raise in body temperature has the net effect of reducing anxiety. The increase in the body temperature, the decrease in anxiety is related to one another. So the increased body temperature, especially increased temperature in certain regions of the brain, he argued, can explain the reduction in anxiety. There is also the thermogenic hypothesis also indicates that these brain regions, when you increase the temperature of those regions, talking is becoming ever more difficult as I record more videos. As you increase the temperature level of these brain regions, you decrease anxiety because the increased temperature in these brain regions allows for neurons to fire more frequently and allows for a greater release of chemicals like dopamine and serotonin and GABA, all of which collectively reduce anxiety. Increased levels of serotonin and dopamine are related to reduced levels of anxiety. Increased levels of GABA, which is more of a sedating type of chemical, reduced levels of anxiety. The drawback of the thermogenic hypothesis is that there isn't really great data to support this theory that brain regions increasing in temperature would then lead to the production and release of more of these neurotransmitters that would alleviate anxiety. So it does need more research behind it. The catecholamine hypothesis suggests that exercise releases neurotransmitters that are collectively known as catecholamines. And these particular neurotransmitters have been implicated in prior research for enhancing mood states, enhancing attention, and increasing our movement abilities, as well as even enhancing endocrine and cardiovascular responses to stress. And so catecholamines, dopamine, again, serotonin, and norepinephrine, which you know from our discussion of stress and the body. Earlier antidepressant medications focused on increasing levels of catecholamines. Before we had SSRIs more exclusively, we had what were called tricyclic antidepressants. And those tricyclic 3 focused on the catecholamines. They increased levels of serotonin, dopamine, and norepinephrine in the brain, and that alleviated depression for a lot of people. So the idea is that exercise, studies show, increased circulating levels of catecholamines in the brain, serotonin, dopamine, norepinephrine, and that enhances mood state, as well as, because norepinephrine also enhances your attentional resources and your movement facility. Finally, number 3, Griffiths talked about what he called the endorphin hypothesis. Now, as I mentioned previously, endorphins are part of our natural painkillers that are made in the brain. And we do know from a lot of research that when you exercise, you release endorphins. Endorphins, these natural opiates in the brain, these natural painkillers, give us feelings of pleasure. And so with increased regular exercise, especially aerobic exercise, you increase your endorphin production, which then when you stop the exercise would downregulate the production of endorphins, much like when people stop drinking or stop using drugs, and now you're feeling withdrawal effects. You're not feeling those pleasures anymore. You're feeling maybe even the reverse. When it downregulates, you're feeling a little bit unsettled. And then that would make people want to go back and continue the exercise in order to maintain the higher level of endorphin release in the brain. Now, there are other interesting provocative studies. Now, I will caution you that these have been done with rats. And as I've said in discussions about sex addiction and food addiction, we always have to take a pause and think how much we believe studies of rats or mice serve as good analogies to human functioning. However, as you know, we can assay from rat and mice brains chemical levels post-mortem that we can't do in human brains. An assay, remember, means that's how we get levels. That's how we test chemical levels. And you can't get accurate readings until an animal or human is dead post-mortem. We can do these kinds of studies with rats and mice. We can't do them with humans unless it happens naturally. Now, so studies with rats, so just keep all that in your brain when I tell you these findings. Research with rats suggests another reason why exercise behavior, once people are doing it more frequently, needs to be maintained at high levels, is studies with rats show that when rats are exposed to extremely high frequent levels of exercise, dopamine levels in particular in the brain change dramatically. And you guys know that when it comes to other forms of addiction, substance addiction, alcohol addiction, sex addiction, food addiction, dopamine has been implicated as playing an important role. The idea is that this intense exercise in rats at first caused a surge in dopamine responses and then eventually depleted it if the rats stopped exercising, because once you're doing it too frequently, remember, just with alcohol and substance addiction, you suppress dopamine levels in the brain, and then the person has to go back to try to get that same level to engage. Similarly, with exercise, the studies indicated the rats exposed to high levels of exercise first released a lot of dopamine, and then it was suppressed, and they had to go back to the high levels of exercise to try to get that dopamine to be released again. If this effect does translate to human brains, then researchers like Griffiths and another by the name of Adams have argued it's possible that hedonic pleasure, remember, hedonic pleasure seeking, that hedonic pleasure that people get from the exercise is now not going to be experienced if the person tries to reduce the exercise level. So they have to maintain that intense level of exercise, if not surpass it, in order to optimally activate that reward circuitry in the brain, that dopaminergic pathway we talked about, that mesocortical limbic dopaminergic pathway. You have to say it slowly or you get tongue-tied, right? Remember that? Mesocortical limbic pathway, where the ventral tegmental area is, and the nucleus accumbens and the amygdala, same area. The idea is that we will need to continue at high levels of exercise to maintain that surge of dopamine to give us the pleasurable outcomes. The mood-altering effects of exercise are available to everybody, but not all people who exercise with increasing frequency and intensity ultimately become addicted, right? Those are individual differences we have to be able to account for, since everybody gets a dopaminergic increase from exercise behavior. And that's when we get into things like we talked about with drug addiction, alcohol addiction, individual differences, gene alleles that might make people more prone to changes in those brain areas when alcohol or drugs are consumed. Similar with exercise. Maybe some people are more prone to these effects of becoming more problematic or addicted because of that dopaminergic pathway and gene alleles that influence that dopaminergic pathway in different ways across different people. Research does show that it shares high levels of exercise usage, behavior, does share three features in common with addiction. People will frequently begin to think about the behavior. They will start to have positive feelings in response to the behavior. They will start to develop tolerance, meaning they have to do more of it to get the good feeling. And the idea is that's because dopamine is becoming suppressed over time in the brain, and they have to up it, right? Up the ante, so to speak, to get the same effect. These factors are biologic, and there are individual differences in genetics that are inherited that influence how these pathways change with any form of frequent behavior, be it sex, be it drugs and alcohol, be it food, and in this case, be it exercise. Of course, the only difference is sex, food, exercise. You're not putting substances into your brain, right? You might be triggering natural substances, but you're not literally putting illicit substances not normally made by the body into your brain. Another thing I want to mention as part of our discussion of potential biological explanations of why people move, right, from being at risk eventually to problem and addictive behavior, is that frontal lobe issues, interestingly enough, have come up in some studies involving exercise dependence. Researchers by the name of Gapin, Etnier, and Tucker linked frontal lobe asymmetry to increased risk of exercise addiction. So the frontal lobe, as you know, is our judgment center, our reflective center, our impulse control center, our rational thinking center. They have found in their research that women who score higher on measures of exercise addiction have increased frontal lobe asymmetry as well. And so what they're suggesting is that as people engage in more frequent exercise, they're starting to create circumstances in which the frontal lobe is not functioning as adequately as it was previously in reducing impulses, in reflecting, in using that sort of executive control it has over impulsive and emotionally driven behaviors. Think about the asymmetry created in drug and alcohol abuse. I told you what happens over time is your frontal lobe, which is your stop system, stop, right? It has less of an effect over time as the mesocortical limbic pathway in the midbrain, right? The go system, go, 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 go. As that go system is repeatedly activated, you start to have an asymmetry in the way the frontal lobe controls those activities and impulses, and that midbrain, that mesocortical limbic pathway, begins to take over, and the go system just keeps going, and the stop system is no longer effective. And this research indicates as these women were engaging in more exercise and becoming dependent according to the criteria we've talked about, their frontal lobe didn't seem to be functioning as strongly as their midbrain, where that dopamine flows in the brain. Now, I should say it's premature to say that frontal lobe changes similar to substance and alcohol addiction can explain what's happening in exercise dependence. This is one study, and there are only really a handful of studies that focus on the frontal lobe. So we do need more research before we can conclude that what's happening in the brains of people who are highly engaged and getting to the point of problematic and addictive exercise behavior. We need more research to indicate that changes in the frontal lobe relative to the midbrain and mesocortical limbic pathway can explain that dependency, just like drug and alcohol studies indicate. We do need more research, but it is provocative that there are some findings in this vein. Okay, I think that is enough. That's a lot of biology, a lot of biochemical information. Please take some time to reflect on it. Make sure you understand it, and then meet me on the next video. I will see you there.